Chapter 13 Computational Thinking. Computer science focuses on using computer to create solutions to problems. Computational thinking is the thought process of creating solutions that can be carried out by a computer. For example, if your problem is then you need to write a book report, a common solution is to read the book, plan out the essay, then write about what you read. A way you might solve the same problem using computational thinking might be to collect data on a number of times each character talks to another and plot information graph. You might even develop a program that analyzes the data for you. The graph would give you data-driven evidence of the relationship between the characters in the story. The output of your program data could be used to tell you what to read in your essay. An extreme example may be to program an artificial intelligence AI program that can understand natural language, analyze the book, and read an essay for you. Natural language, the way people speak in each other. While this example might not help you meet your goal of learning about the book, it shows how far computational thinking can go. In computer science, artificial intelligence (AI) is a powerful way of programming machines and computers so they can learn from large amounts of data to improve the way they work. This type of computing allows computer programs to make predictions and decisions beyond those that they are directly programmed to make. There are four major ideas in computational thinking. 1. Decomposition, breaking a problem down into simple parts. 2. Pattern recognition, identifying what different problems have in common. 3. Abstraction, separating details that matter from details that are not important. 4. Algorithm design, creating a solution with simple steps that anyone can follow. Decomposition, before beginning work in a solution, you need to understand all the parts of the problem. Once you understand each part, you can break the problem into smaller tasks. Decomposition makes a problem more manageable to solve. For example, when writing a book report, you would break an assignment down into smaller, simpler tasks. Read the book, identify the main characters, identify the theme, analyze tone, plot, and character relationship. Write about the tone, plot, and characters in the book. Decomposition helps to identify where to start and the task that needs to be completed. Pattern recognition. Patterns are the events that are repeated. Recognizing that you have created a solution to similar problem before will help you create solutions that can be used to complete different tasks. For example, if you use the format as a template for writing book report outline in the past, you can include the same process in your program. A book report outline may be different, but the process of writing the report is the same. Abstraction. Abstraction focuses on the important idea of the problem and ignoring detail that will not help you find the solution. For example, focusing on an important part of the book, like the relations between major characters, the setting, or the theme, and not on less important information like conversation between minor characters or daily event, help you create a problem that's not specific to one book. The program would work with books that have different plot but include major characters, settings, and themes. Algorithm design. Algorithm design means writing out the steps you need to follow so that you can get the same solution every time. When a solution is carried out by an algorithm, the solution becomes reusable. learning to code, process chart, skill, knowledge. Unit 5, Universal Programming Principles. Chapter 14, Variables. In math, a variable is a letter to symbol used in place a content you don't know yet. The variable is a placeholder for a number of in mathematical expression or equation. In computer programming, a variable is a container for storing a value. A variable is stored in the computer's memory and can be used or changed throughout the program. Variables act as stand-ins or placeholders for values that are stored in the computer. The name of the variable is the identifiers. The information that the variable contains is the value. Variable values can be text, numbers, or other type of data. For example, the scores in a computer game is a variable. In the game start out 0 and the players earn 1 point. Here's how the variable would work. Value, identifier, variable. The program finds what the variable values for score is the store, then replace the previous value of 0 with the new value 1. Assigning and naming variables. To create a variable within a program, you have to declare to create a variable within a program by giving it a name. When you declare a variable, you are telling the computer to create a space for information and to assign the space a name. It's like organize a bunch of toys using box on a shelf. For each type of toy, you pick a box, label it, and put the toys inside the box. To assign a value to a variable, use the equal sign equal. The identifier goes on the left of the equal sign, and the value goes on the right. You can assign a new value to your variable anytime you want. The equal symbol is called an assignment operator in programming because it's used to assign a value to a variable. Assignment operator. The equal symbol which assigns value to variables. In program, the equal sign doesn't mean equal, it means is assigned. Name equal JSON means that the variable name is assigned the value JSON. There are specific rules for how you can identify or name variable. Different programming languages may have different rules, but the common rules are: variable name should be short and should clearly describe what the variable represents. This works, score. This doesn't work. This variable represents player 1 score. Too long. Variable must begin with a letter of the alphabet. This works. First player. This doesn't work. First player 1. Variable can contain letters, numbers, and some characters like the underscore. No reserved characters like sharp at %, or space are allowed. When you want to use no reserved characters or space are allowed. No allowed. And you want to use more than one word to name a variable, you can use the underscore symbol instead of a space or use uppercase letter to start each word is no space between words. This work. Post underscore player or post player or post player. This don't work. Some words already have special meaning within a program and contain be used as identifier. These words depend on which program language you are using. For example, Python uses a letter return to produce a value of an expression or function. There are some reserved words you can't use for naming in Python. Python reserved words you can't use for naming. True, false, import, and, not, if, or else, return, none, why, and leave. Type of information variable can store. Variable can store many different types of information called data types. String value. String. Variable can store any kind of character, including letter, number, symbol, and special characters. For example, in a quiz program, you could use string variable to store a question and answer in program. String is always placed inside the quotation mark. Example, name, Alan Turing. String, fruit, underscore, salad, yummy, gummy. Variable name, identifier. Identifier, variable name, string. Numeric value. Variable can also store numeric value, including integer, positive and negative whole number, or floating point number with a decimal point. For example, we can use a variable to store amount of time it takes a player to complete a level in a game. Do not use quotation marks with numeric value. Example, variable name identify numeric value. XP equal experience points used to show the player's character's advancement in a video game. You can use algebraic expression and assigning value to variable. For example, we can use a variable to store the experience points a player has and add 5 points to the value every time they reach a goal. Score equal x plus 5. You could also use math to add a point to a score variable. For example, to add 2 points to a value, we can use score equal 5 plus 2. Because score is an integer variable, it has the value of 7, the sum of the integer values. But if you made score store a string by putting 5 plus 2 inside the quotation marks like this, the score is storing the string value of 5 plus 2, the actual contents within the quote. Boolean value. Sometimes programmers need to know something is true or false. For example, in a game that they want to know if the game is over or if it's still going, or did the user get a quiz question right or wrong. When the information we want to store is true or false, can also be yes or no, then we can use another data type called Boolean, pronounced Boolean. Boolean variable can only have 2 possible values, true or false. Boolean variables are named after the English mathematician George Boolean. For example, I like licorice. False. Variable name, identify. power up, true, game over, true, brilliant name. List, an array valuable stores entire list of information. This is useful when you have multiple pieces of information that you want to store in one place. For example, in a hangman game program, you could use a list array to store all letters the player guesses. Each time the player guesses a new letter, it would be added to the end of the list.